Welcome back. In this video, what we're going to do is we're going to explore the concepts of integrating things that involve natural log and exponential functions. Now, we don't actually integrate the ln of x because that would require integration by parts. What we do is we integrate equations that can be formatted this way as 1 over u du. The antiderivative of that would be the ln of the absolute value of u plus c. Because remember, the derivative of the ln of u is going to be 1 over u times du dx, basically. And so we can go the other way around. We don't integrate ln of u because, like I said, it involves a technique that we don't do necessarily. I don't beat you up on this absolute value, but it technically should be there if the function can be negative. So just be careful about that. On multiple choice type questions on the AP exam, they'll have that absolute value there. So in this first example, we can write this as 1 over u, because if u is 3x squared minus 5, then du is going to be 6x dx. This x right here combined with that dx is that's it right there. So 1/6 of du is x dx. So when I rewrite this in terms of u substitution, I'm going to write a 1/6 out front times the integral of 1 over u du. Antiderivative is ln, so it's 1/6 ln of the absolute value of 3x squared minus 5 plus my constant c. Second example, same idea. Okay, so u is going to be 9 minus 2x. So du is negative 2 dx. When I rewrite it with an integral, I'm going to multiply it as negative 1/2 times the integral of 1 over u du, which is negative 1/2 times the ln of the absolute value of u, 9 minus 2x, plus my constant. Whenever you have something like this where I'm dividing, okay, so I'm taking 2x minus 1 and I'm dividing by a monomial, you want to divide each one of these individually by that x. So if I take 2x over x dx minus the integral of 1 over x dx, this one here, the x's will cancel, and I'm just taking the antiderivative of 2. So that's going to be 2x minus this one here is going to be ln, so the ln of x plus c. Anytime that you can take anytime you have a monomial in this denominator, make sure you always divide that out. That's going to be the easiest way to do it. Exponential functions, if you have something like the antiderivative of e to the u du, it is just e to the u plus c, because remember that the derivative of e to the u is just e to the u times du dx. So it's the same idea. So in this example right here, the exponent, the 3 over x, that's what's going to be u. So u is 3 over x, or 3x to the negative 1. Du is negative 3x to the negative 2 dx, or it would be negative 3 over x squared dx. So when I rewrite this in terms of u and du, I'm going to multiply by negative 1/3. That this x squared dx, that part right there, is negative 1/3 of du. So it's going to be negative 1/3 times the integral of e to the u du. Antiderivative of e to the u is e to the u, so negative 1/3 times e to the u plus c. And then, like I said, I put u back in. So it would be negative 1/3 times e to the 3 over x plus c. That exponential, that's the easiest one. It's the easiest derivative too. It's the identity function. One little trick we get in here, and that's integration involving some long division. Because in this problem, if you try to let u be x plus 3, then this x squared minus x plus 4 dx is not going to be its derivative. If you let this be u, this 1 over x plus 3 is not going to be the derivative. So what you can do is you can do long division. So I can take and rewrite this integrand. If I take x plus 3 and then divide x squared minus x plus 4 by x plus 3. Long division, focus on that first term. So how many times does x go into x squared? Just x times. So that's going to be x squared plus 3x, multiply through. Subtract. When I subtract, the x squareds will drop out. The x's will be negative 4x. Bring down that 4. focus on the first term. How many times is x going to negative 4x is minus 4. So it's minus 4x minus 12. Subtract. This is going to be 16. Remember, 16 is our remainder, so I can rewrite it as plus 16 over x plus 3. So what I'm going to do is I'm going to rewrite that integrand that way. If I rewrite this integrand as x minus 4 plus 16 over x plus 3 dx, I can integrate each one of them individually. The antiderivative of x is just x squared over 2. Antiderivative of 4 is minus 4x. Now this antiderivative is going to be plus 16 times the ln of the absolute value of x plus 3 plus my constant. Algebraically, if you're having a little bit of trouble with this long division, I'll clarify in class for you the best I possibly can. All right, good luck. I'll see you back soon.